the last category of types of CNN, which is ResNet and DenseNet. So let's see what are they. So you're seeing already different types of CNN architectures. The next architecture that we are going to see is ResNet, which is also known as a deep residual network. The other name is ResNet. Now, this particular type of neural network architecture was designed to overcome the challenges of training very deep neural network, because till now what you have seen was VGG13, VGG8, VGG16. That is, the number of the layers which were carrying the weight parameters were like 13, 16. They were very less. But when you compare to ResNet can go as high as ResNet 101. So that means like the number of the layers over which you can have weight parameters are more. So this particular ResNet was designed to overcome the challenges of training a very deep neural network, and this was introduced by Keming and team, and it was actually like a technical paper which was presented in the conference on computer visions and pattern recognition in the year 2016. Now the motivation for ResNet was like, because when the number of the layers of the neural network get increased to a large extent, that we call it as the depth of neural network increasing. So as the depth of neural network increases, the training accuracy saturates and then it degrades rapidly. Why does this happen? This happens due to the problem called as vanishing gradient. Okay, so vanishing gradient is a problem that we will see more in detail when we study RNN. So this phenomenon is right now, it is called as vanishing gradient, because of which training accuracy gets saturated. Basically, the gradients, when you are moving back in back propagation calculation, it becomes very, very small, which makes it's very difficult to update your parameters and makes challenging for the learning to happen. So ResNet overcame this. Because it used residual blocks. So what are these residual blocks? The residual blocks, they contain a skip connection or a shortcut connection which will bypass one or more layers which are not needed. Okay, so the idea was to learn the residue or the difference between the input and output of the block. Now this will allow the network to focus on to the learning the residual information, which helps you to make the training easier. Now in this you make use of identity mapping, wherein to the input of a residual block you will add directly the output of the block. So if x is the input to a residual block and f of x is its output, then the residual block is going to compute f of x plus x. So this will allow the gradient to flow directly during identity this will allow the gradient to flow directly through the identity mapping during the back propagation, and the gradient does not vanish. Now ResNet architecture, if I want to see, if I talk upon the bottleneck architecture that involves convolutional layers, you have got three types of it, which is 1 by 1 convolution, then 3 by 3, and then 1 by 1. So first 1 by 1 convolution layer is used to reduce the dimension of the data, and then the next one is going to increase the dimension of the data, thus making the computationally efficient network formation possible. Now if I talk upon after convolution, after convolution and pooling, which goes hand to hand, you always have a dense layer, that is, you have fully connected layers. But ResNet has got a difference here. Instead of using fully connected layer, it uses global all average pooling at the end of the network. Apart from that, it also uses batch norm layer in order to stabilize your training and to normalize the activation functions that you are using. This is a typical ResNet 18 diagram that you are able to see. Here the main motto was to to explain you how average pooling is happening, and then followed by this is a very small part of a ResNet architecture basically. Here you are using all 3 by 3 convolutional layers, but you can see how the increase are there in the number of parameters that it is going to deal with. Like that, you have got many different types of layers inside ResNet architecture, and it is basically when I call a ResNet architecture can actually deal with the various depths of CNN layers. That means different versions of ResNet architecture are present. Now this if I begin is the starting what you can say, it's the initial architecture of a ResNet 18. You have many others like ResNet 34, ResNet 50, ResNet 101, ResNet 152 based upon the number of the layers. So you can see till 512 layers are also possible with ResNet. So very deep neural networks it is going to train without any problem of gradient being vanishing and without any problem of learning being deteriorating. Now talking on DenseNet. Again, this is a technical paper. This type of architecture was like a technical paper which was presented at Computer Vision and Pattern Recognition conference in 2017, and it was introduced by Gao Huang and his teammates. DenseNet was known for its dense connectivity pattern wherein each layer receives input from all the previous layers, creating dense connections within the network. So you can see in DenseNet, every layer is connected to every other layer in a feed-forward fashion. And this dense connectivity pattern that we call the feed-forward fashion, it will help you to flow the information and gradients throughout the network. Thus, what will happen? Every layer is going to receive the feature maps from its previous layers as its input, including its own feature map as well. So the learning is good. Now, the dense connectivity is achieved through the use of dense blocks, specialized type of architectural blocks you're going to use, wherein a single dense block is going to consist of multiple layers, and every layer is going to produce a set of feature maps. Now, these feature maps, they are all concatenated and they serve as an input for subsequent layers. You can see this is the DenseNet architecture that you can see. You have got all dense blocks which are interconnected with each other. Every dense block have got its n number of layers which will be connected to the next dense block, but in between there is a transition. So we'll see it. What is it? So now a dense block consists of multiple layers which are going to produce its own set of feature maps, and then they are concatenated, and then the dense blocks, this dense block structure actually enable you to reuse the features and enhance the learning capability of a network. Now I come to the architecture of it. If I talk on the bottleneck layer, then the bottleneck layer or the convolutional layer is a composite layer here with a combination of 1 by 1 and 3 by 1 convolution layers. It is going to help you reduce the dimensionality of the feature map and making the network more and more computationally efficient. Now you can see that in between the dense block there are transition layers. Why they are required? Basically they are like pooling layers. Why they are needed? Obviously to reduce the spatial dimension of your feature maps. And then the transition layer consists of you have a 1 by 1 convolution layer and a pooling layer, basically average pooling. All of these will help you to control the number of parameters, thereby computational efficiency is going to be more. So you can see here, similar to ResNet, DenseNet also uses global average pooling in place of fully connected network at the end of a network. Also similar to it, it is going to use batch normalization to, stabilize your training throughout, and the activation function that it is going to use is ReLU. Now you can see here, this is a typical DenseNet block. Here given an input, there are various dense blocks which are used. Inside it there are several layers of convolution, but each of these blocks are also connected to each other through these transition layers, which is nothing but a 1 by 1 convolution layer and average pooling layer, and at the end you are going to predict it. And as I told you, it is going to use an average pooling layer in place of a dense network. So this was about ResNet and DenseNet. You are free to choose your data sets and use different types of CNN architectures as per the data set which is in hand, and have your architecture made, make several changes and then select the one which suits you the best.